What we have here is a very typical question, shows up on trig or pre-calculus algebra 2 tests, where we're given 4 equations and 8 graphs to match with. And this is really typically a difficult question with a lot of points. So this video is the first of the series of 4 videos where I'll graph the first 3. And then on the 4th one, we'll do analysis. So let's get started. This is one of the first videos. What I have here are standardized steps on how to find or graph any of those functions we're given. Step number 1, we're looking for holes in the denominator where the function is not defined. So for example, this one and this one here, when we set the denominator equal to 0, x is going to be at minus and plus 1. And that's where the function breaks off because the function is not defined for this case. And for this one over here, x equal to 1, the function is not defined. The reason we want to find the holes is because then we can examine the vertical asymptotes of the function. What happens when the function close to the hole where the function is not defined? Typically, function, of course, blows up on one end and goes positive infinity and negative infinity on the other side. And that's why the function is not defined. After finding the vertical asymptotes, we're going to move on to finding horizontal asymptotes. That's when the x is either really large or really small. What happens to the function? What's the behavior of the function? And from there, the very last step is we're going to look for special values, and that's when x function cross x-axis or y-axis and or y-axis. So let's go through this series of 4 videos, and we're going to follow exactly the 4 steps, and let's have some fun with this. Alright, so step over 1 here, we copy the first function. We can see when we set the denominator equal to 0, there's 2 holes, x equal to 1 and minus 1, where the function is not defined. Having found the holes, let's go on to step number 2, which is examine the vertical asymptotes. Alright, on step number 2, we can see right around the holes, when x equal to 1.001 or minus, 0.999 from either side, the function does blow up. So, so far, just by those 2 red vertical asymptote behavior, we can cross out this one, and we can cross out this one. So, as a matter of fact, let's do that. So, let's cross this one out. Cross this one out, because they don't break at the function where we said it's going to break at plus and minus 1. That leaves 1, 2, 3, 4. 4 more functions that could possibly be the answer. Let's do the number 3 now. With number 3, we can see for the horizontal asymptotes is taking large value for x and see what happens to the function. As we can see, given this function here is going to be a really small positive number. From here, of course, we can cross 2 more. Because, as you can see over here, this one is, as x large to 1, it does not close to 0. So this one is out, and so is this one. So, and as well as this one, because the value does not close to 0. And our number choice left is only number 3 now. So number 4, step number 4, we'll just verify that graph number 3 is the correct one. Here, last step here, our function does not cross x-axis because it keeps on approaching to 0 but never gets to 0. And when x equal to 0, substituting in there, you see that function takes value at minus 2. So 0 minus 2 is a point on the function, on the curve. So therefore, for the number 1, the first graph, 3 is the curve. Here's a quick summary. So the first graph is matched by number 3 over here. We examine the end behaviors. We also examine the vertical holes, and all the end behavior leads to graph number 3. Well, I hope this helps. Hi, this is Dr. Pan recording from Tucson, Arizona. Please comment or share this video. Hit the like button. Together we can make math easy again. Have a confident day.